Okay, hello and welcome to my channel. Today we're gonna be solving problem 1, set 3 from MIT OCW course 805, Quantum Physics 2. Okay, so this is a spin problem. So let's begin with A. So the question for A is you're given an unnormalized spin state, which is this minus 1 plus I root 3 minus your ask what direction does it point to. Next is B. B is a bunch of word. Okay, so I'll attempt to draw some sort of visualization for you. So step 1 is you prepare a beam of spin 1/2, all in plus states. So we don't have to consider the before, which is passing it through a Stern-Gerlach device to get the beam. Just gonna consider the beam. So only plus. First, I'll just draw it as well. Z, so this part is blocked, only plus. Then past these atoms, another Stern-Gerlach to get an N, right? So this is N. Only have eigenvalue plus h bar over 2, and you have theta equals 0. Theta is not 0, but phi is 0. Okay. So I suppose it's like this. Next, you pass through another z direction Stern-Gerlach device. And this has 2. So okay, I suppose it looks like this. So what fraction are found by the third magnet to be in the state plus? All the atoms that enter the second magnet. So meaning what fraction? If 1 is found in 3 to be plus state. Oh, minus and blocked. So the answer will be, this is a hint. Answer will be in theta functions. Okay, argue that this makes sense for argue theta equal to 0, pi over 2, and pi. This better be a square bracket. Alright, that is what we have to do today. So let's begin with problem A. Problem A is, well, something pretty easy, and you have like a formula for it already. Just polarize what you're given, then you compare it with what you got from the formula and what you got. So basically this is what you're given. Now we put it in this form: c plus state plus c minus state. And this in the block dimension is, well, cosine theta over 2 plus ei phi sine theta over 2 minus. This is the form. Okay, so now we're going to consider c minus over c plus, which is ei phi sine theta over 2 over cosine theta over 2. This is, of course, just the tangent. So we got something to compare what we're going to get later on to. Okay. So now we polarize C plus and C minus. You can do this with a calculator. So I won't be writing the steps because I just don't remember how to do it. I just put it in the calculator and get what you need, which is root 2 e I pi over 4. Polarize the second one plus root 3 minus, I forgot the minus sign. This is 2e I 4 pi over 3. Okay. Now we're going to calculate c minus over c plus again and see what we have. It's root 4 e I 4 pi over 3 over root 2 I pi over 4. I put root 4 so it will be easier to do the thing. It's just the same as 2, so doesn't really matter if you don't want to put it like that. 13 pi over 12. Okay, now we can compare. From 1 and 2, 1, 2, get that tangent of theta over 2 is equal to root 2, and just 5 is equal to 13 pi over 12. There we go. This is like the standard formula for you to do some problem like this. So this one is the easy one. Next is B. I think, yeah, B is not that hard. We have now the direction as well. Oh yeah, the direction. So we have to put it in cosine and sine. Lazy. Oh my gosh. Anyways, let's do it. So first, let's do cosine. Cosine, we have tangent. Trig identity. 1 minus tangent square theta over 2, 1 plus tangent square theta over 2. Next is sine. Sine is just 1 minus cosine square theta. You can calculate these, and the direction, it's going to be n sine, cosine, sine, and cosine. Cosine. This would be your direction. Okay, so now we're going to move on to B. B is not that hard, but kind of weird to imagine. So first thing you have is the first step. You're gonna get a pure plus state. Next one is you pass it through the Stern-Gerlach device in n direction. So n direction plus, it's going to be, you're also given that, second one, given that the phi is equal to 0. So n plus is cosine theta over 2 plus sine theta over 2 minus. And the probability that would goes out, so P out here would only be the plus or the cosine square. And from here we can get our fraction loss. So loss is gonna be sine squared theta over 2. Okay. So this is in the second region. This is in the second region. Now we're gonna move on to the third region. And so here, right here, yeah. To the third region, we have a P plus and P minus since we have both beams. Okay, we'll calculate what made it through here. What's gonna make it through? So that would be the probability out of our second part times the probability of this. Okay, I'm thinking of a way to explain it a little bit clearer. It's like you first have a plus beam, you pass it through a Stern-Gerlach device, then the probability of it going out is only the plus state is going to go out, and the rest is going to be blocked. Then that one beam is going to go in another Stern-Gerlach device and going to give you two outcomes. So either plus or minus, that is what it is here. So to calculate the probability from the start to finish, you gotta time them together. Okay, so I'll write it now. Went through. It's going to be P out times P plus. P out times P minus. This is plus, okay, that is cosine to the fourth theta over 2. This is cosine squared theta over 2. Sine squared theta over 2. Okay, and 2 is failed. Failed is just what is lost. So fail is gonna equal to loss and equal to sine squared theta over 2. Now we're gonna have to argue with theta equals 0, pi over 2, and pi. Actually, just put them in a calculator and just put in the solution. It's gonna be the argument. Okay, so argument for first, theta equals 0, so z direction. And put them in, put these two in the calculator. And theta equals 0, so of course your minus is going to be 0 for the sine. So what is left is just the P plus. Therefore, so, all right. Only plus states. Okay, next is theta equal pi over 2. This is when it's in the z plus direction. And you put pi over 2 in here. Okay, and what you get is 1 to the 4th for this, 1 to the 4th for this, and 1/2 for this. So what you get is half of it is gonna out, and half of it is gonna be blocked. And try to calculate P plus and P minus, I mean like these two. I cannot find a name for these. You just call them that. You gotta get that like these two are going to be equal to each other, which is 1 to the 4th. So 1/4 is going to be plus, and 1/4 is going to be minus. There you go. And next is the minus z direction, which is theta equal to pi. Theta equal to pi. So only the failed is going to give you solution, which is 1. So you can say that this 100% of this is going to be blocked. And there we go. That's it. Pretty hard to understand, but really it's actually very easy, like math-wise. But it's hard to grasp. I don't even know how to explain it clearly. But then these are the solution. Okay, so that would be it for today. Goodbye.